Today I will create a fully procedural bricks pattern with shaders. Now I will be using Unity for the demonstration, but you can apply the same logic in Unreal, Godot, Blender, or almost any other platforms. I also have to point out that the end goal of this video is not to show you how to get the end result, but to show you how you can play around with numbers and use maths to achieve cool looking effects. I'm Digvijaysinh Gohil and welcome back to the channel. Alright, so I've gone ahead and applied this shader to my quad in Unity, and if you don't know how to write shaders, I have 4 video series about the topic, so you can definitely check that out. Now to draw anything procedurally, we need UVs, and UVs are just vector 2 that goes from 0, 0 up to 1, 1. Let's quickly just visualize that. So v.uv and 0. So for my quad, UVs goes from 0, 0 here up to 1, 1 here. And now let's say I want a black border on the left side of my quad, so for that I can use step function. So I'll just go step of, let's say 0.2 and d.uv.x. So what step function does is, if this input is less than this input, it will return 0, otherwise it will return 1. And as a result, I will get this black bar at the left side. So this 0.2 is the size of that black bar, so I'll just use a variable for that. And I'll make it float for now. Equals 0.2. And I will replace that here. So that shouldn't change anything. Now let's say I want the border at the right side. For that, I can simply flip this input, and instead of size I will go 1 minus size. So that way I will have the bar or black border at the right side. And if I want to combine those two, so I want both the bars at the same time, I can simply go another step of size and UV's x and simply multiply those two together. So now I have bars at both sides. Similarly, if I want vertical bars, I can simply use UV's y component. Like this. Now let's say I want all 4 borders at the same time. First, I will just change this to float 2, and then instead of just y, I will simply go UV. And now I have error because this entire thing returns vector 2, but my color is vector 3, so I'll just simply go, let's just declare it, and then I'll go color dot rg equals the entire thing. And now I have this because I've stored the values in my colors red and green channel. I just want the white values, so I'll simply go color equals color dot r into color dot g. Hit save, and now I have a white square with black borders around it, and I can control the size from here. Now you can of course make the size as property, but this is just a demonstration, so bear with me. And I can also just have different horizontal and vertical border size. So I'll go float 2 of 0.1 and 0.2. So I'll have the thicker vertical borders. Pretty cool. Now this is only a single square. If I want multiple squares, I can simply tile the UVs. So let's declare a float2 variable called UV, and I'll just use the original UV and multiply another float2. Let's go 4 by 4. Actually, let's just store it in a new variable. So float2 tiling equals that, and here multiply tiling, and let's use our UVs. And I know this looks weird, but why that's happening? Okay, so here I multiplied my original UV with 4, so now this UV goes from 0 0 up to 4 4. Now here if I use fraction of that, so UV equals fraction of UV, and this fraction function simply returns the decimal part of the number. So if I go 1.5, I'll just get 0.5. Now one important thing to note is, even if I pass negative value as input of the fraction function like minus 3.2, the fraction function will return positive 0.2 as the output. Okay, so if I hit save, now I have multiple boxes. And now you might say that, okay, this doesn't look like bricks at all, so let's just fix that. Okay, so the very first thing is I want to stretch the bricks on the horizontal axis, so I'll simply go 2 here as tiling. And because I've done this, now you can notice that I have thicker border here than this one. So let's fix that. For that, I'll just get the aspect ratio, and I can get that by going float, let's say aspect equals tiling.x divided by tiling.y. And then with this aspect, I'll just modify my size. So here I'll go size.x multiply equals my aspect. And by doing that, I have a consistent border size. Pretty cool. Now, I don't want an extra line here, so I'll simply do this. Get rid of this. That shouldn't change anything. Now let's say I want to offset this pattern, and for that I can simply add some numbers to it. So first I'll go float offset, and I want to offset it 0.5 units horizontally, so I can simply add that offset here, and let's just go float2 offset and 0. So now I've just shifted this entire pattern 0.5 units to the right side. Now let's say I only want to offset the alternate rows of the pattern. So how can I do that? Okay, so let's modify this offset so that the offset will be 0 for this row, then 0.5 for this row, again 0 for this row, and 0.5 for this row. To do that, I can use my UV's y component. Here I'll go offset equals uv.y. So right now my UV's y goes from 0 up to 4, because I multiplied it with 4, and I'll just go f mod of that, and let's divide it by 2. This f mod function will return the remainder of uv.y divided by 2. So by doing this, I'll get values that goes from 0 up to 1.999, like almost 2, but not exactly 2, then again 0 up to 1.9999, and so on. Alrighty, then I can use the entire thing as the step node input, so I'll just go step of 1 and this entire thing. So now I will have positive values for every alternate row. Okay, and let's just visualize that for a second. So I'll simply go color equals offset. So now you can see that I have all black values, then white, black, white again, and so on. Okay, and then here I can simply multiply the original offset, or I can just do offset multiply equals. So now I've shifted the alternate rows of my pattern, and now it looks a lot like bricks. Let's adjust the tiling. Let's go 8. And now let's say I want to alternate the offset once every 2 rows, so I'll simply go 3 here. So now I have 2 rows similar to that, and then one offsetted, then again similar. Now let's say I want to offset the pattern a tiny bit more for every 4 rows and then repeat. So first I'll just go make a smaller offset, and instead of step I'll just go F mod and 4. So now I have the offset that looks like this, but I want the straighter line, so I'll simply use the floor function. And floor function simply returns the integer part of the input. So if I input 1.5, I will get 1 as the output. And I have some pattern like this. And now let me adjust the offset a bit so you can see the irregularity. Okay. Now let's say I want to offset it for every 3 rows and then repeat. So I'll just simply go 3 here, and let me adjust the offset as well. So I'll go 4, 2, 1 for example, and I have some irregular pattern like this. Alright, this is all cool. Now let's make a separate function for the patterns. So first I'll go float bricks, and it will take UVs as an input and tiling as an input and size as an input. One more offset as well. Let me move this here and the size here. Then I'll just cut this entire thing, paste it here, discard this, simply go uv.tiling. This is all cool, this is all cool, this is all cool. Instead of half 3 color, I'll simply go half 2. Let me call it pattern. And I'll do this and simply return. Then here I'll simply go have 3 color equals, I'll call my function bricks, pass in the data, so v.uv, my tiling, my offset, oops, my size, and offset. And that shouldn't change anything. That's pretty cool. So now I can use this function, and one cool thing is I can just take this out. Alright, in Unity, let's make a text file. So here I'll go right click, new text document. Let's call it procedural patterns, and I'll change its extension to HLSL. Back in Unity, open that up and paste my function here, hit save. And now in my brick shader, I can simply include that file. So go hash include, and it's procedural patterns HLSL, and now this bricks function will simply work. So this way, if I want to use my bricks method in my other shaders, I can simply include this file and just call my bricks method. That's pretty cool. And you can apply the same logic in shader graph as well. one more cool thing is you can also use your procedural pattern HLSL file in the shader graph using custom nodes. So let me quickly show you. Let me first create a custom node or custom function. Select it, and in the graph inspector here I will just select my source HLSL file, in this case procedural patterns, and then here I will use the name of my function, which is bricks. Then here let me define my inputs. First one is UV, which is of type vector2. Second one is tiling, which will be of type vector2. Third one is offset, which is also vector2. And the last one, third one is size, and the fourth one is the offset, and it's of type float. Then outputs. But before I've declared any outputs, I had to go back to my shader file. Here I need to change a few things. First, instead of returning a float value, I'll simply go void, and then I will just define an output parameter here. So out of type float, and I'll also call it output. Then instead of return, I'll simply go output equals this, and then head back over here, define the output. It is output of type float, and I still have this error, undeclared identifier bricks underscore float. That's because I have to append the precision of the shader graph, which in this case is float, so underscore float. And let me adjust the inputs. So let's pass in the UV. For tiling, I'll simply go 3.8, size will be 0.2.2, and offset will be 0.432. So now I have a custom node with my bricks pattern. Pretty cool. And that's all I have for you today. If you enjoyed this video, hit that like button, and if you're new to the channel, please consider subscribing for more videos like this. That's it from me, and I'll see you in the next one.